The finished airboat looks right at home on the water. But rewind to the beginning, and this entire build starts with chicken wire. Fragile, flexible, and full of holes, it looks completely unsuited for what it is about to become. He starts by shaping the mesh into circular frame sections, creating the first pieces of the airboat's hull. Using nothing more than pliers and tin snips, he trims, twists, and crimps every wire end by hand, joining the separate mesh sections until the outline of the boat slowly begins to emerge. Once the frame reaches the desired length, he closes the two rear ends with cone-shaped mesh pieces. Now he has the boat's basic form. But there's one problem. It's full of holes. Drop it into the water now and it'll sink instantly. He must build a watertight hull. His solution? First, he lays sheets of paper over the frame and tapes them down. Next, he begins applying fiberglass cloth along the main length of the frame. He works section by section, cutting the cloth to size. The paper underneath gives it a surface to rest on, stopping it from sagging through the open mesh. For the rounded ends and remaining exposed areas, he switches to chopped strand mat, a woolly type of fiberglass that is easier to press into curves the woven cloth could not cover smoothly. To make the hull extra durable, he adds more fiberglass layers across the main body and slathers on another coat of resin to bond everything together. He has to work quickly, because once the resin begins to set, it becomes much harder to shape and smooth. With the fiberglass cured, the open hull shell is complete, but the boat still needs a curved floor inside. To create that curve, he uses a sheet of plywood as a mold. He starts by marking a center line at one end of the board. This part must be spot on. If these lines are off, the floor could end up uneven, and the boat may not sit straight in the water. He uses a flexible PVC pipe as a guide, bending it across the plywood and tracing matching curves on both sides. This is where the board needs to flex. He cuts open the center lines he marked earlier, giving the board room to bend. Next, he trims away the excess along the side marks. With those outer strips removed, the plywood can flex into the floor profile the hull needs. Now he starts drilling pairs of holes all the way along the center cut. They're not random. Each one will help pull the two sides back together into one smooth curve. He stitches the board together with zip ties. As he pulls it tight, something interesting happens. The flat plywood board naturally bends into a smooth, continuous arc. To help the rest of the panel take on the right curve, he positions wooden strips along the edges and nails them down. These aren't part of the actual boat. They're just temporary anchor points for the next step. Now comes the clever part. Using the wooden strips, he stretches ropes across the plywood and tightens them bit by bit. With each pull, the panel settles into a deeper, smoother curve, creating the shape needed for the hull floor. A strip of tape goes straight over the stitched center seam. It hides the join and leaves a much smoother surface for what's coming next. Here's a little workshop trick. He spreads margarine across the entire mold. This creates a greasy release layer, stopping the resin from bonding to the wood. Without it, removing the finished hull floor from the mold would be a nightmare. The mold is done, and now it is time to build the floor. And yes, there's plenty more fiberglass to come. Fiberglass is the structural muscle of this boat, giving the hull its full strength and rigidity. He lays down the first layer over the mold, carefully trimming away the excess around the edges. Next, he brushes on resin, soaking every thread of the cloth so the fibers bond into a sturdy floor panel. One layer isn't enough. A second layer of fiberglass goes straight on top and is lined up carefully over the first. He coats the second layer evenly with resin. When it comes to the bottom of a boat, the thicker, the better. Doubling up gives the hull extra structural strength and guarantees a completely watertight seal. Once it's completely cured, it's time to see if that margarine trick actually worked. He starts raising the floor off the mold, and it pops straight off without sticking. Next, he gently lowers the floor into the open hull shell, carefully positioning it until it sits neatly in place. Using fiberglass and resin, he bonds the floor to the hull shell, turning the two separate pieces into one solid structure. With the lower section secured, it finally looks like a boat. He adds two bottom strakes to the underside of the hull. Like guide rails, they help the airboat go straight in the water instead of sliding sideways. But the hull alone can't carry an engine yet. One major piece is still missing: the transom. This thick wooden plate closes off the back. With great care, he eases the pre-cut piece into position, then nails it right into the structure, creating a solid rear wall that will firmly hold the engine. The engine's thrust will push the entire weight of the boat from this point, so the transom needs serious strength. To reinforce it, he coats the joint in fiberglass and resin. The boat is coming together now. The hull might look finished, but it still needs support. Row by row, the builder fits PVC pipes across the floor. These serve as the boat's ribs, keeping the bottom from flexing every time someone steps aboard. A thick layer of fiberglass cloth to be coated with resin goes over the entire grid, fusing the pieces right into the structure. Together, they stiffen up the deck while sealing the inside against leaks. Dropping steel plates down onto the ribs, he sets up the main mounting frame for the engine. He welds the frame to the steel supports, joining the components into one solid rig. He then moves straight to securing it down. First, he drills through the frame and into the transom. Then he drives thick screws through the holes, clamping the engine mount firmly against the back of the boat. Over the engine mount, he sets an arched canopy frame, then drops the driver's seat right up front. To make sure the canopy frame won't move, he layers fiberglass and resin around the feet of its base, bonding them tightly to the hull. He moves down to the engine mount, applying the same composite wrap for a firm bond to the floor. Finally, the legs of the seat get the same treatment. The boat is now ready for painting, but before that, with long strips of masking tape, he maps out a pattern across the outer hull, running lines down the length of the body. Shorter strips are applied to the rear sections, completing the pattern. The first coat of paint goes onto the main body. A soft gray is selected for this section. He moves over to the taped pattern, and bright turquoise fills the masked sections. Suddenly, this no longer looks like a homemade project. Now, it looks the part, and he doesn't forget the frames. This is where the builder's genius really shows. Most people would buy a propeller, but he decides to create one from scratch, carving it by hand from a solid block of hardwood. Before shaping anything, he uses a ruler and pencil to map out a precise grid, laying down straight reference lines to keep the blades perfectly centered. To get smooth, sweeping blade shapes, he bends a flexible strip across his reference points. It's a classic technique used when drafting clean, flowing curves. Now the real shaping begins. Using a rotary wire brush, he shaves down the hardwood block. Layer by layer, he gradually brings out the actual profile of the blades, turning that block into a true aerodynamic propeller that will slice through air and generate real thrust. Now, for the propeller hub setup, he drills out the large shaft hole first and sets the metal hub over the middle to mark the precise spots for the mounting bolts. He then brushes on a generous coat of varnish on the propeller, bringing out the natural grain while shielding it from moisture and sunlight. This gives it a sleek, finished look, not quite bad for something carved by hand. Now, for the main deal, he unboxes a brand new petrol engine and lifts it onto the rear metal frame, lining it up with the pre-drilled mounting holes. On a build like this, the engine must be mounted rock solid. If it shifts even slightly while running, the propeller angle can change, throwing the boat off balance. At speed, that turns a simple mistake into a dangerous ride. To connect the propeller to the engine, he slides a 3-inch aluminum pulley straight into the motor shaft and gets it positioned just right. He carefully screws in the pulley's bolt and then works a T-bar spanner around the bolt to clamp it down solid so it doesn't budge under power. Above the engine on the mounting frame, he sets up the propeller shaft and fits a larger aluminum pulley onto it. He loops a drive belt over both pulleys connecting the engine to the propeller shaft and pulls it tight so there's no slippage when the motor spins. With the drive belt in place, he returns to the propeller mount. This time he slides the metal hub onto the end of the shaft, positioning it as the anchor point for the propeller. He then fits the custom wooden propeller onto the hub, drops the bolts in position, and prepares to secure it to the shaft. Reaching around the back, he threads the nuts directly onto the bolts by hand one by one. He grabs a spanner for a final crank on each nut. Next, he works on the belt tensioner. He positions a small wheel directly against the drive belt, carefully lining it up and bolting it in place right before hooking up its tension spring. Right behind the propeller, on the canopy frame, he mounts the two vertical air rudders. He links them together so they move at the same time, secures each pivot point, and checks that they swing freely. With the rudders set, he runs a long linkage rod to the steering lever beside the driver's seat and fastens it. The linkage rod has to stay straight and properly aligned. If it bends or shifts off-center, the rudders may not move smoothly, making the steering stiff and unpredictable. He installs a motorcycle-style twist throttle right on top of the lever, runs the wire, and fastens it down, so it stays neat. Easy speed control right at his fingertips. We will see how that works in a moment. To test the boat, he yanks the starter cord, and the engine roars to life. The carved prop turns, and the air rudders snap back and forth, right on control. He is satisfied with his handiwork. Look at that gentle smile. With help from a friend, he hauls the airboat down to the riverbank and drops it in, ready for a drive. No expensive factory tools, just chicken wire, fiberglass, and clever craftsmanship. He fires up the engine, and everything responds. Like a dream, the boat glides off effortlessly across the water. Now look at him go! And just like that, this custom airboat is complete. For many local fishermen, this is how access to the water begins. Not with expensive machines, but with creativity, patience, and the ability to turn whatever is available into something that truly works. And that is it for this video. For more projects from this builder, check out BKS Creative on YouTube. His channel is linked in the description box. As always, be sure to subscribe to Techfreeze for more builds, more stories, and plenty more projects just like this. See you next time.